Okay, well, good afternoon, everyone. So today our goal here is to finish the data wrangling. We're gonna have a quiz, so stay tuned. And then we're gonna start our yield editor exercise as well. I uploaded a script for that second part of today's class. You don't have to download or retrieve it right now, but you will have to retrieve it once we shift and finish this exercise. All right, so for us to always start on the same page, coming here to our 07 yield monitor project, and then launching it through the rproj. Always remember this, always want to launch it through the rproj and not just by double clicking a script. So I'm launching that on my side. We see we're in the right project. We're looking at that 07 yield monitor on the top right. And let me see here. I believe we stopped here last class. So for you to, if you're seeing the outline, if you're not, you can toggle on and off that outline button. If you're seeing the outline, you can come maybe to this. Let me see here. Let me just make sure. I think we stopped right here, right? Is that what you have on your side? So on the yield restricted map, Aman, is that what you have on your side?
Yes.
Yes, okay, thanks, Polly. All right, so where we stopped, if you did not leave any errors in your code above, which I guess you shouldn't, then if you just come to this chunk where we stopped and you click this button here, it's gonna run all chunks above. If you have no errors in the chunks above, then it's gonna work completely all right. And so that way you get the object created. We have, all the outputs generated again, and so on. So there's not a lot of stuff back up there, but there was some of it. So if you remember, our goal here was to do some wrangling on this object, which right now, we had a conversation about this just being a tibble, is just a data frame. And it does have X and Y columns for the coordinates, but it is not a geospatial object yet in R. But we're just doing some EDA, right? So we made a yield map here to look at the distribution of the yield data points. So we color the data points by yield. Then we restricted to only keep values less than 3,000 pounds of lint per acre. And we ran that. So we can tell that when we filter, because remember we had a few points here on the yield data distribution, we had only a few points that were larger than 3,000, probably data points that had, errors associated with them. And so if we just on the fly do a filter out to only keep those less than 3,000, then make a plot again, because those three outlier points were basically pulling the color scale towards them, then it was harder to see by color the differences in the map. But then once we remove them, we can see better some of the patterns in this map here. And this is, of course, just a static map. All right, so I'm assuming everyone was able to just rerun until this point. If you were not, or if you're having any trouble, let me know. Now, you all read the paper, so you're aware that speed can have an impact on yield errors associated with yield monitoring. And I want to look into that relationship between yield and speed. So I started off for us here. So I'm doing a ggplot, bringing this yield 17, which I'm going to print below so you can see it. I'm putting speed on the X and yield on the Y. If I want to look into this relationship, I need to add some geoms to be able to visualize that relationship. right? So what would be the first geom that you would add here? So if we just go ahead and run what you have there, it's just going to be the empty canvas, right? We have speed on the X, dry yield on the Y. The range of the X's are already set for us, but there's nothing in there. We have to add a geom to visualize the data. If I want to look into this relationship, what geom would you bring in here? Holly, what do you think?
Um, I'm thinking, I'm not sure what we can apply, but if you can do like a regression analysis to see how the change of speed can affect the change of yield, but I don't know which geom specifically to use.
So that's the direction I want to go. So just think about it, like how would you, for you to do a regression, what would be the geom you need to first show the data before you do a regression on it? Like how would you show these pairs of speed and yield on this plot?
Line.
Okay, we can do a line. We can try that. Let's try it. So do a plus geom line. Okay. So what geom line is doing is basically connecting every pair. I think that is not exactly what we want, but I think Amandeep here has an idea. Okay, so Amandeep is saying geom point. Let's try that. Okay, so it's not like a beautiful scatter plot because the nature of the data where we have the speed is only like an integer values. Or maybe perhaps not integer, but it's not like a continuous variable that can take any value. It can only take 4.0, 4.1, 4.2, and so on, right? So it's at every 0.1 increment. But yeah, geom point is what I was envisioning as well, just to look into the scatter plot. Now, Polly, to your next point, I wanted to see some way of a regression line or a pattern line or just something that gives me an indication of the pattern of this relationship. I do not think, let me see. I don't remember if we saw this function yet, but maybe we did and I don't remember. Can someone have a guess of what would be the function that we'll add here to see that, to put a line here and show that relationship between yield and speed? What did you say? LM? Okay, so LM would be a modeling function. And even though it's what would happen behind the scenes, but it's not a geom itself, right? So there is a geom we can add here to give us that information. So given that I don't think we've done that yet, I'm just going to give you the answer. So there is a geom called geom smooth. If you run that, it's going to run a smooth line through our data points. So this smooth line here is basically, it is a regression that's being run behind the scenes, but it's a squiggly line. It allows you some flexibility to go up and down. So it is a loss type of regression. But that helps us to visualize the overall pattern, right? So what is going on here? Let me ask maybe Benedetta. How would you, so given the points and also using the line that we just drew here with geom smooth, how would you interpret this plot?
So I would interpret that there is a lot of variability for sure.
Okay, great. What else?
Another thing is that when the speed is lower, the yield is higher. And so probably this is an error in collecting data, probably.
Yes, that's a really, really good observation here. So I hope you all can see that maybe after like 2 miles per hour, there's still variability, like Benedetta mentioned, but it looks like this squiggly line is kind of, reaching this equilibrium sort of. It's going up and down a little bit, but it's reaching some equilibrium on yield. However, we do see those very high yield points coming from very low speeds. And that's something that you read on the paper, right? So low speeds can have a problem creating high yielding points just because of the way that you're still moving slowly and the time it takes to fill the header and for that to go through the combine and hit the weight plate where it's taking an assessment or an estimate of yield. So there is a relationship here between speed and yield, and we see that all of our very high, or except one, so except for this point here, all of our very high yielding points are coming from very low speeds, which is a good indication that maybe they are truly errors, right? Because of speed as well. Awesome. Thanks, Benedetta. Okay, so I think at this point you're probably well, we explored a few things here, right? So we explored just restricting the range of data points to only those less than 3,000, which in fact just removed maybe a few points, not a lot of them. And also that there is this relationship between speed and yield that we should take into account when cleaning this data. So, from just a map quality, a data quality perspective, we do have evidence that we need to clean this data. And at least with the information that we have right here on this data set, let me just print EO17. On the paper that you all read, there were 14, I think, filters, something like that. Some of those filters we can more easily implement in R than others, and I will focus on those. So we're going to implement here filters that are going to be based on yield and on speed. So speed and yield are going to be the ones that we're going to implement. Now, what I want you to think about is the following. If you have this data set, the EO17 data set in front of you, right? So we have about 32,000 rows, 18 columns. If we have to wrangle this data to make this data to be a little bit more direct and just overall easier to handle when we do the yield mapping exercise afterwards, what would be some of the wrangling steps that you would do? I mean, I guess I have some of the answers here that you can see already, but if you have not seen the answers, this is just some steps that I thought were interesting to do. It doesn't mean that all of them are required. Perhaps even on your side, you may think of some extra ones that I'm not thinking, which is completely fine. But overall, a few things I want to do here is I want to standardize column naming style for our ease of use. I want to select just the columns that really are needed for us to keep moving forward, which are going to be speed, dry yield, and then the coordinates. So normally when I'm working with data, I like to have short column names that include the unit of measurement. That is really important, especially if you're working in the US, as we all are, because sometimes you're going to get some data that is going to say yields. And depending on the crop, depending on the unit that yield is in, it's going to be difficult for you to just guess if that is that kilograms per hectare, is that bushels per acre, what is it, right? So given that in the US, we work back and forth between English and international units, it's really key to have our units in the variable names. I like doing that, and I highly recommend you do that for your own sake. So I want to include units on the on the column names, which right now they don't have, right? So if we just check yield 17, we have like elevation, for example. I think it's feet, but there's nothing there. You know, speed, I think is miles per hour, maybe it's kilometers per hour, I don't know. So all of these things that have important units, we do want to know what are those units. I also want to create columns in the metric system. So we're going to have the English and the metric system. Finally, I want to transform this into a spatial object because right now it is just a data frame, as we've been talking about. And then we need to transform from geographic to projected. So this is basically a list of steps that I think we need to do with this data set. And what I want to help you to see is that with wrangling, a lot of times, you may not know exactly what function you need. You may not know what package, how you translate that to code. Then that's fine. But what I think is a very key skill for you to develop is just in your head trying to think, okay, this is what I'm starting with, and this is what I think you should look like in the end. And then make a roadmap of what steps you have to do to go from this to that in between. That's super, super helpful. That's something I do all the time, and it really helps me because all these scripts, I basically came up with them, right? They were not somewhere else out there that I just been giving you from someone else. I came up with them, and a lot of times the way I come up with them is just thinking like that. I have this data that I'm beginning with. I want to get to this point. What are the in-between steps we need to do to get there? So all these scripts are based on that principle, and this wrangling approach is also based on that. All right. I guess any questions about these steps? Would you do something else that I'm not proposing? Okay. So let's get started with the wrangling then. I left you here the code at the chunk for starting with the raw data and then applying a clean names right off the bat. So you're familiar with that. We've done this before. We're just standardizing those column names to something that's going to be easier for us to manipulate afterwards. And then notice how I took each one of these tasks that I just wrote in plain English and made comments in my code. Now I want to ask you to basically code under them as we move forward. So the next step here after clean names, please go ahead and add a pipe. What I'm proposing we do next is select just the desired variables and renaming some of those variables. So can somebody help me here? What function do we need? Okay, dplyr select, right? So let's call that. All right, so that's the function. And then I have a list here of the variables that we want. I want to check below. So remember that now we apply clean names, so their names change. So when we do the select here, we're going to have to use the new names below. So let's see. Kiathi, tell me a few variables you think we should include here, given the new names that are printed below.
Can you give me a second? I'm looking at the names. What? I don't see any columns in my data. I don't know why.
So maybe make sure that you don't have a pipe active here, because if you have it active and you run, it's going to try to run. Yeah, so
Sorry.
let's run that part.
Okay. I think we need the speed for sure.
Okay, I like it. I agree. So speed is one of them. What else?
And then the point X and point Y, and then the dry yield.
Awesome. I totally agree with that. So point X.
Point Y.
And then, oops. Point Y. And
And the
then
dry yield.
let's just check here. How is that spelled? So dry underscore yield. Awesome. Okay, I agree with that. I think those, We could bring in more if we were doing more other filters, but at least for this exercise, these are the ones we need. And then, so I want to select some variables, but also I want to rename some of them to include the units. So we could use another function after this. We could use a rename function, but the select function allows us to also rename kind of on the fly. The way that that would work is you would come here. So let's say if I want to rename speed to be speed underscore miles per hour, I would give the new name first. So speed underscore mph, and then say equals to speed. If we do that and you just run this and you print it, you're gonna see that now speed underscore miles per hour is what we have there. I want to do the same with dry yield. So I want to rename dry yield to say yield underscore LBAC for pound per acre. This is the unit. So make sure you do that. And then once you print it, you're going to have it renamed to that. All right. So the next chunk, just give it a pipe. I left you the function here just because I didn't want you to be typing a lot of decimal points. So add a pipe and then just remove the comment from mutate and the line below. So it looks like this. So we're basically taking yield in pounds per acre and then applying the conversion factor to kilograms per hectare and then creating a new column for that. And the same thing for speed. So those are just the conversion factors right there. So if we just run this and then you print yield 17W, you should see your initial columns, right, of speed, miles per hour, point X, point Y, yield pound per acre, and then yield kilograms per hectare, speed kilograms or kilometers per hour. All right, so we have both English and metric and international system units. The next thing is going to be to transform this into, so up until now, still yield 17W is just a data frame. Now, the next step is I want to transform this into an SF object. I'm trying to think if we have done this before. Have we? Okay. With other. Yeah, okay. So sorry that I don't fully remember this for this class, but next step here, just add a pipe and come after that transform into an SF object. Let's see in Tifton. Can somebody help me? I think we talked about this in lecture, maybe we implemented an exercise already, but can somebody in Tifton help me to remember what is the function I need here to transform something from just a data frame into an SF object, which is a geospatial vector data type?
ESSF.
Yes, thanks, Benedetta. So st underscore s underscore sf is going to be that function. It has an argument for coords, which is we telling that function what are the columns that have the coordinates. So we're going to use the C function because there are two coordinates. And then we need to give in quotation marks point underscore x and point underscore y. Remember, if you give it flipped, when you map it, you may be somewhere in the middle of the ocean, maybe in Antarctica. If that happens, a good place to check is that if you gave your x and y in the correct order when you're transforming it. So if you run this to here and you print EO17W, now notice that it is an SF object. It gives us those two panels when we print. So it is a simple feature collection, an SF object of type point. And then it gives us a data frame that is exactly as before on the side. Notice how now the data frame itself does not have point X and point Y anymore. It actually has a geometry column that's being transformed or that took those coordinates, those columns, point X and point Y, and then transformed this into a geometry, which is what makes it an SF object. Now, if you come back here to the first panel of printing this object, you're going to see that it does not have a assigned coordinate reference system, right? That's because this is a data frame that had no information about CRS. And so when we transform it to SF, SF does not know what is the native CRS. We can most certainly guess that this is WGS84 because that's the most common CRS that spatial data is collected, and also because of the units. It makes sense that this would be so if we are in the US, it would be a negative value on the x-axis, which is your longitude, and a positive value on your x-axis, which is the latitude. All right, so it is an SF object. So we just went, notice, to go from data frame to SF, this is the function we're using, STSSF. That's a really key function that I want you to remember. Now, the next thing, because this was a data frame and had no CRS information, we have to assign the native CRS first. So if you give it a pipe here and come after that other comment, let's set the native CRS. So this is not the CRS I want it to be, it's the CRS that was collected under, right? So WGS84, let me go to Tifton again and ask, what function should we use here? And I'm gonna ask Luke. What do you think, Luke?
Let's see, is it SF set CRS?
Okay, it's close enough. So it is actually ST underscore set underscore CRS. Thanks, Luke. All right, so in here, it has an argument for value. This is the EPSG value of what is the native CRS of this data layer. Does someone remember the EPSG of WGS84? Nice. Amandeep said 4326. I think she's been using a lot this CRS lately. She's nodding yes. All right. Yeah. So this is the APSG code for WGS84. If you run it and then you print it, now it says geodetic CRS WGS84. Awesome. However, we at some point are going to do distance-based operations on this object, meaning that we have to have this on a projected CRS instead of a geographic CRS or geodetic CRS, which WGS84 is a geographic CRS. We want to transform it to a projected one. So let's give it a pipe here, come after that comment. And then the last function of this pipe workflow is going to be transforming to a projected CRS. I'm not going to ask you to remember the specific EPSG of what we need here, but I will ask somebody to help me with what function we need here. If we go back to Tifton again, is Mohit there?
Yes.
All right, Mohit, what do you think we need here? So a lot of these functions that within the SF package, they start with ST. So you can do an ST underscore and kind of take a look at what comes up. And you can tell if it's from SF package because it shows on the right. You know, if you're trying to get a refresher, maybe that could help you, although there's a lot of functions, so maybe it's too many, but it's for sure here. Can anyone else help Mohit here?
Transform?
Yes, right? So we want ST transform. And then here it has a CRS argument, and this we give the CRS of what we want to transform into. In our case, it's going to be CRS that has an EPSG code of 6345. If you run that and then you print it, now we see that it is a projected CRS with NAD 83, UTM zone 16 north, exactly what we needed for this field here. All right, so, you know, these set of functions specifically, I do want you to remember them. There's not a lot of things I ask you to remember, but these are some of them. So if to go from data frame to SF, ST is SF, to set the native CRS, ST set CRS, and then to transform to a different CRS, ST transform. And I want you also to notice how these functions, as part of the tidyverse philosophy, they have names that are very intuitive, right? So they really make sense when you're trying to think about it. What would be the function name? That is by design, is just to make us, be able to remember them more easily and not be something very obscure. All right. So after this point here, I want to make some new maps. I left you the code here, but maybe I shouldn't. Because, so we're starting with yield 17, we're filtering just yield pounds per acre less than 3,000, and then we're feeding that into a ggplot. Now, yield 17W is an SF object. So now, because it is an SF object, we need to use geom_sf as the geom. And we do not need to give X and Y coordinates because that is implicit because we're using geom_sf on an SF object. So if you run this and you look at the result, it looks very similarly to what we did before. The difference is that now we're actually plotting a vector geospatial file, or if not file, but object that is of type SF. And because of that, we're using geom_sf. For contrast, if we go back to the previous maps, before we transform to SF, so yield 17 is just a tibble, and we're using geom point and explicitly saying what goes on X, what goes on Y, right? This was a data frame, whereas this is an SF object. So this distinction here of understanding what type of object is the one that you're working with and how that changes how you plot it, perhaps some of the operations you're going to make, it can be important. So I do want you to realize those distinctions and why they happen. Any questions? All right. So what I want to do next is do an interactive map with this data. And I do want to filter the 3,000 here. So if you come to this chunk, we can give it a pipe. And what function do we need here for an interactive map? Say that again. Map view. So I'm going to do set map view. That's right. If we just go ahead and run this, it may take just a quick moment here to run, but then this is what we get. Not very friendly or useful. It's just a whole bunch of points. Also, I think this is a good point to show. So remember that some of the first maps we made here, maybe, yeah, this one here. And I was asking because it looks like it looks like a continuous layer, right? But the reason for that is just because there's a lot of points overlapping. If we could zoom in into this map, you would see the gaps between the points at some point. Now that we have an interactive map, we can zoom in and see those gaps. So if you come here and you just zoom in, at some point, there's going to be a gap between the points. Meaning, or another way for us to really checking that this is not a raster. And we already knew that because it's an SF object, SF is for vector. But, it's harder to tell when you're looking from a zoom out perspective because there's so many points that looks continuous, but it's not. Okay, so here I want to make a few changes on this interactive map to help us to better visualize this. So first one, I want to change what is the column that's being used to color the points. If you remember, the argument here is called zcol for the color of the z variable. And the z variable, I want it to be yield _LBAC. If you don't want to So if you run this again, you can do if you wish, but it may take a little bit of time to go through because there's so many points. So I'm gonna make a few changes in the code before we run it and inspect it. The next one is I want to change the color scale that we're going to be using here. So there is an argument called whole dot regions. It doesn't pop up there, but it is there. And here I want to use the function Virides, which comes from the Virides package that we loaded on the first chunk. And I just want to give it a value of 3. So if we run Virides 3, it basically gives us 3 hash or hex codes for 3 different colors within the Virides color scale. Before we run the code, I want to make one more change, which is going to be to change the size of the points. If you remember, the size was really large. So I want to change that. The argument is called CEX. I want to change it to 0.1. I think the default is 1 perhaps. So maybe now we can go ahead and run it just to inspect what these changes made. So this is how that looks like. It's kind of hard to really see the colors because there is an outline on the point. So then that outline is black. So when you zoom out, all you see is the point outline. I want to remove that outline. So if you come here, there is an argument for LWD. I think this is for line width. I want to say 0. So that basically decreases or removes completely the outline of the point. All right, so now we can really see a lot better. And then finally, I want to change on the code to give it an Esri world imagery base map behind. So we come here, we give it a comma. The argument is called map.types. And the name is uppercase E Esri dot uppercase W world uppercase I imagery. All right, so this is what I wanted to do, wanted to look like. If we come here, so a couple of things is you will need to create the map exactly like I did here to answer the following quiz we're gonna have. So if you're not able to reproduce this, then let me know. All right, so assuming that you are able to reproduce this, if you come here on the hamburger symbol of the map, try to toggle yield on and off. I know the last class when we were trying to do this, I was having issues on my computer. I think some of you were also having issues, but at least for me, at least today, it is working correctly. So I can toggle on and off yield. I want to just give it a moment and ask if somebody's having trouble with this, or if somebody's not able to toggle on and off and see the base map.
Dr. Bastos, I don't see the S3 world imagery. It's completely blank except the map. I don't know.
Did you include this exactly as I have here?
Yeah.
So uppercase,
um,
then a dot, and then uppercase W, uppercase I.
yeah, it's the same.
Okay. Is anyone else having that problem? Okay. Kathy, I'm not sure why that's happening on your side.
Mhm.
But I'll help you out when it on the quiz, at least with the visualization, which you're gonna have to answer this.
Okay.
All right, so right now we're gonna do a quiz. So go ahead on ELC. All right, so we have a quiz 3 available. It's called yield data errors. So here's what I'm asking. Based on the interactive map that we just made here for the 2017 raw yield monitor data, where in the field do you see low yielding areas? Of these different low yielding areas, which ones do you think can be related to yield monitoring errors and why? So I want you to tell me, I see low yielding areas on this part of the field, on that part of the field. And you can use north, south, border, inside, whatever you can use in words to tell me where in the field you see. So I want you to tell me where you see low yielding values. And of those, which ones do you think could be related to yield errors and why do you think that? So for you to answer this, it's just going to be on text. You just answer directly on ELC. And a tip that I have for you is when you are here on that map, toggle on and off the yield map, and try to understand what is going on, why certain areas may be low yielding, and relate that to yield errors, potential yield errors. So toggling on and off so you can see the base map behind is going to help you to perhaps try to make a connection between the data that we see, the features of the field, and also what you read on the paper as far as some of the sources of field errors. Any questions before I start a timer for your quiz?
Dr. Bastos, could you open up the quiz on the other class as well? I don't have access to it.
Yeah, sorry, Luke. Let me do that as well. Well, let me do this. I'm going to start the timer. If you want to start working on it, just like if you want to open like a Word file, Luke, and just start answering. And then once the 5 minutes are done, I'm going to have it pulled up on the on the other class as well.
Yep, thank you.
Awesome. All right, Kiathi, let me see.
I don't see the quiz. Like I don't see the question or anything.
Oh, yes, sorry. Create new. Yes, I forgot to add a question. So just a written response. See. Okay. All right, so I think this should be fixed. Can you all see now?
No.
But I think it's because we entered already and there was nothing.
So even if you close and come back, it's not gonna.
So it's telling us to continue the quiz.
Okay, sorry, then let me fix that. So I'm going to basically remove this. I'll delete it. So if you can't just exit the quiz, I'm going to. I'm just going to delete the quiz and then create a new one. I'm going to call quiz 3.2. All right. check it out if you can see it now. Hmm?
Yes.
Okay, is it working for everyone except Luke, because I haven't copied yet?
Yes, it's working.
Okay. So Kiathi, let me do this. I'm gonna. So I think this first map may help you to identify where the low yielding areas are. So maybe you can use that to write the first part. And
Okay.
once you finish that, let me know and I'll toggle this off so you can see behind it.
Mhm.
And let me set a timer.
Dr. Bastos, I don't see a quiz here.
You're not
I
seeing-
think no, I'm not seeing the quiz.
Have you refreshed?
Yeah, I did.
Hmm.
I tried to open the quiz, the previous one. Maybe it's because I left in the middle.
Yeah, so what you maybe try to like log out of VLC and log back in and see if that helps, because I think it should be there.
Okay. There's one in the list. I didn't see it on the homepage, but there is one quiz in the list.
Okay, nice.
Yeah, I'll answer that. Yeah, thank you. Dr. Bastos, can you toggle the
Mhm.
data off? Yeah, please.
So I'm gonna toggle on and off a couple times. And then I'll leave off. All right, so our timer is up. Luke, I just created or copied this quiz to the other course. If you want to check that out and let me know if that worked.
I see it, thank you.
Awesome, thank you. Okay, so let me pull up here some of the responses and take a look at them. Okay, so I guess let me ask some of you to share your thoughts. I mean, would anyone like to share what you observed? So maybe, you know, if I just turn on yields here, you know, where do you see the low yielding points on this field?
I think what I see from the map, that most of the yield points are on the edges of the map,
Okay,
of the field, sorry. So I think on the edges, there may be the harvester which can slow down. So there will be, because of that, it may read give the low yield reading. So that may affect the yield monitoring data.
Okay, so Amandeep here said that she noticed low yielding points near the boundary of the field. She said it could be because of speed, but I think it could also be because of, well, a couple of different things. So we can kind of see that the row pattern is in this direction, almost north-south. So there is a different pattern on the boundaries where the combine is making, or in this case, a picker, where the picker is doing the maneuvering, right? So there's some errors associated with the south and the north parts of the field on the boundary because of that maneuvering to turn around and go on the next row. That can be associated with speed and also partially filled header, right? But then as we think on the west and east boundaries, especially on the west one, that's almost a straight line, maybe the speed was not changing as much here, but it could be because of just partially filled header, right? Maybe they started on the east and moved west, and when they got to the west, maybe only half of the picker had rows to be harvested. If their planter and their picker don't have the same number of rows. Right, so yeah, so it could be, those could be some errors associated on the boundary. What else did someone else observe here as far as where you're seeing low yielding points and how that could be related to, or how would you explain them?
I think that there was also low yield on the stripes, those stripes in the middle of the soil, where there's an even pattern of the soil, and maybe that will be associated to the combine slowing down so they can pass through those stripes.
Yes, that's a great point, Polly. So, you know, maybe if you're not, I mean, I don't think you would know this field necessarily, even though it's a very popular field in Tifton, especially for those working with row crops. But you know, these lighter color soil that we see here, these are eroded parts of this field. So water is basically draining from the west to the east, and it creates these gullies of eroded soil, which means that when the picker is going over them, it is probably slowing down when it's getting into them and then speeding up when it gets out of them. So there's that speed differential because of this field shape or the terrain properties of this field. Also, some of those yield points are probably still low, right? Doesn't mean that is because it is a low yielding point that it's an error. Probably those parts of the field are low yielding as well because it is eroded soil, so it's lower in fertility, lower in water infiltration, and so on. So it could be a mix of both, and then becomes difficult to really know, is it an error or is it just because it's a low yielding part of the field anyways? Probably is mixed, right? But some of it is probably related to errors because this changes the speed of the combine as it's moving over and through those gullies. And then something else that you wouldn't know just from the base map, but just to let you know. So you see there is a very low yielding part of this field right there. This is because this is a point where water accumulates. And so basically plants die there because, they get waterlogged and the roots cannot respire and the plants die. Or maybe they're very little vigorous. So there is this low yielding part of this field that could also to some extent be related to errors, but also because it is low yielding because plants don't survive there very well. Awesome. All right. Well, thanks everyone for your comments here. I will go through your specific comments on the quiz. There is really no right or wrong answer in this case. I just wanted you to be interpreting the data that you're seeing, making that connection between the data, the sources of error that you already read on the paper, and some potential issues with this field in specific as it relates to the terrain. All right, so our last thing of this script here is going to be to export this data to file. Something I want you to notice is that a lot of times we're going to be developing our workflow throughout the entire semester, and we're going to start getting more complex as time goes by. If you think of all that complexity, we're basically chopping it up into different scripts, into different projects, meaning that because they're connected, we have to export the files that we already, in this case here, wrangled. We have to export them to file because we're going to need to bring this wrangled version back into the next exercise. So for us to still have scripts that are doing a very specific task, so this is doing the wrangling, the next one is going to do the yield editing part of it, and so on. We need to bring raw data, work with it, explore, plot, make maps, fix what we can on that script, and then export to file. So the next script would just bring in this exported version rather than doing the wrangling every single time from zero. So here on the exporting, I think we've seen this already, but we're going to be using the function write_sf. The first argument here is the actual data, the object name that has our SF object. So that is yield17w. We give it a comma, break line. Let's give it a path. So I want to export this to the data folder. So we need to go up a level, .. hit tab, go on data. I want to call this specific file yield17_processed.geojson. So remember that on the write function, we give basically on this argument, we're given the path, the file name, and the file extension all on the same string of text, right? So that's what we're doing there. And before you run it, I do want to caution you of the following. I think we talked about this already. There's an extra argument that I want you to specify every time you use write_sf, which is delete_dsn equals to true. What this does is the default is false. So if you don't change the default to true, what happens is if you run this chunk twice, then the first time is going to export this yield17 to this file that we just assigned on data, which now you should be seeing on your data folder if you ran first time. So this file here has, let's see, let's print EO17. It has 30, almost 32,000 rows. If you run this piece of code again, without the delete DSN equals true, it's basically going to or not overwrite, but it's going to append your current file. So if you run this twice and then you import EO17 afterwards, it's gonna have twice as many rows because you just appended the same file twice with the same data, which is not what we want, right? So then doing delete DSN equals true, it makes it to overwrite instead of append, which is what we want in case you need to run this chunk more than once. All right, so if you exported, and you can go check on your data folder, you have this EO17 processed.geojson there. Great, that's all we needed. Make sure that you save your script. I want to ask you pretty much to close the script. And if you come here on your on the environment, you can click on that broom icon, which is going to basically clear all of your objects. That's okay, don't fear. Nothing bad has happened. We just cleared our environment to start new. So what I want to do next is so our class today is until 4. We have about 30 more minutes. I will give you a 5-minute break, but before that, I want to instruct you to download again GitHub. So the GitHub repo, I have a new file for you there. So download that GitHub repo. You're gonna see a script for EO17 editor or something like that. It's the latest script under the 03 or 04 class code folder from GitHub. So download GitHub on the 04 class code, the latest script, which has today's date on it. Copy that and paste inside of the code folder. While you do that, I'm gonna give you 5 minutes break just for you to stretch if you need, and then we'll come back. And when we come back, we're not gonna have time to move the script again. We're just gonna start from that point. So make sure you do both of those things before the break. right, so our timer is up. Let's continue here. So just very quickly, does anyone need more time to get to this script? So the one that we're going to be working with now. All right. Don't hear anything, so I'm assuming you were all able to get it. So the previous script, we were just doing some wrangling, especially related to, as you remember, what we did there was inspect the data set, select some columns, do some wrangling, transform it to geospatial, and then export to file. That's all we did before. We did not do any filtering of any sort on the previous script. This script here that we're going to be working with is going to be specifically for that. We're going to be using some wrangling functions again. But the goal today, or with this exercise, is going to be to do the wrangling, or the wrangling related to yield editor functions. As I was telling you earlier, we're not going to be able to implement all the functions that are on the software yield editor that you read the paper about, but we're going to be implementing, I believe, 6 of the total 12 or 14 filters. I don't remember exactly now the number. So with that, our goals for this exercise are going to be to learn and implement yield monitor data cleaning steps in R. And then we're going to compare numerically and graphically raw and clean yield monitor data and understand, some of the trade-offs between cleaning the data, removing data points, and then, what are some of the effects that has on the final product. So these are the list of packages we're going to be using today. I think you may not have Leaf Sync. And I don't remember if you have Patchwork. So what I would do is, if you just have your cursor on the first library function, just run line by line, right? So command return or control enter, just run line by line. And if you get a red symbol on the left, then it probably means you don't have that package. So if you don't have a given package, you can just remove the comment and install, which I've just left you there, the 2 that I think you don't have. But if so basically just use the install packages if you need, and remember to either comment it off or delete that whole row after you install those packages. All right, I'm gonna get started with the code, but if anyone needs more time after we start using some of these packages, if you need more time to install them, let me know. But we're going to import our data first, right? So remember, we always do a setup where the first chunk is loading the packages we need, and then we import the data. So I want to import the data that we exported on the previous exercise that we just finished. And I want to assign that to an object called EO17W. What function do we need here? Let me ask Benedetta. So Tifton is muted, just to let you know if you're saying something. I'm not hearing you.
So
I was saying that I was installing packages. Can you repeat the question?
Yes. So what I was asking is, we want to bring back the data set that we just exported from the previous exercise, or bring that file into R.
Read the SF and then we write the file.
Yes, read SF, right? And that's because what we just exported is a GeoJSON file. If it was still a CSV or an Excel, it would be read CSV or maybe read Excel. Because it's already an SF object, read SF. Thanks, Benedetta. All right, so let's do read SF here. And let's navigate to that file. So we need to get outside of the code folder. We exported that to the data folder, and then it's called EO17 process.geojson. So make sure you navigate to that. And once you run it, it should pop up on your environment. I did ask you to clean your environment before starting here. If you did not do that, please do that and then bring this data. And that should be the only thing you have up there. And if we print it, we know it has about 32,000 rows, and it has just the columns that we created on the previous step, on the previous script, right? So we have a wrangled version of it, and now we're going to clean it. As always, we start with some EDA, so checking the summary. We see here again the range of values on speed, on yield. Everything looks okay, at least, even though we may have some data points that we're going to remove based on some of the algorithms on that paper. At least these values make sense. We don't have negative speeds, we don't have negative yield values. So from that perspective, we're okay. All right, I want to make a raw or a map, a static map of the raw yield data and assign that to an object called yield map raw, because I want to be able to call this map again later in this script. So I left you a little bit of the code there. So we're starting with a ggplot where the data set is EO17W. If you just run what you have right now and you print it, it's just going to be an empty canvas. So I want to make a map of this yield data. What geom do we need here? Let me ask Luke.
Sorry. Let's see. Sorry, is it just you said you wanted a map?
Yeah, so we want to make a static map of this object EO17W.
Okay. I don't remember. Is it just geom SF or geom
Perfect, geom SF, right?
Yeah.
Because it is an SF object, so geom SF, that's perfect. All right, so I do want to, so if we just do that and we print it, we just get this, which on a static map is really not that useful. So I want to do a few changes here. One of them is I want to color these points according to yield pounds per acre. Mohit, how do we do that?
Fill equal.
Sorry, say that again.
Fill equal.
Okay. Then what?
Yield.
So we need to give the column name, right? So the column name, if we just print EO17, the column name is, let's do yield pounds per acre. So this would be how we would say it. Let's try that. Let's see if that's going to work. All right, so it's telling us object yield pound per acre does not exist. Holly, how would you fix this?
I'm not sure.
Oh,
Yes, Benedetta, did you have something to say?
yeah. NA equal true.
NA, I guess. Oh, okay. Yes. So you're saying here. So I think that this is a problem more that it's not finding object pound per acre. So I think there's something wrong with the way we're specifying here. Kiathi, what do you think?
You said we have to do an aesthetic map, right?
Yeah, so it is a static map.
Yeah, shouldn't we use AES?
Yes. AES is the key here. So every time we think I want to change the color, the fill, the size, transparency, according to a column in my data set. So yield pound per acre is a column in our data set. that has to go inside AES. That is the key. So if we just put here AES and put the fill equals yield pound per acre inside AES, make sure you have your parentheses right. So we need to have 2 at the end. That would fix it. Almost. The thing is, right now, we want to have actually color equals yield pound per acre. So let's do color instead, and that should fix it. Right? Okay. So something we've done before I want to repeat here is the size of the points are just too large. So I want to change that to something smaller. We come back to GeoMSF outside of AES because I want to change the size to a fixed value and not to a variable. We say size equals 0.1. So the size of the points is decreased. And then finally, I want to change the color scale to Viridis to be colorblind safe. Let's see. Amandeep, how do we do that? Okay, let's use the Viridis C for now, just to check. Okay, so Amandeep said to use scale fill Viridis C. Let's see if that's gonna work. Okay, so it did not work. And the reason for that is because we said scale fill here, but we're changing the color. So it has to be scale color instead. Okay, nice. So now we changed, and now that for now at least I'm okay with this. We don't need to make this publication ready. I'm fine with this map, but we can keep moving forward. So I left you almost all of the code here, but I also want to create a raw. So this is the raw map in raw map static that we just created above. I want to create a raw map interactive. So for this specific case, I am filtering. So starting with ELW, filtering yield below 3,000 pounds per acre, and then putting that inside a map view. So I'm giving you already the Z-col, the col regions, the alpha regions. This is for transparency. I'm making it completely solid, changing the size of the point. And then there's a few more things that I want to change here, which are the same things we changed before. I left you 3 dots here. So make sure that you remove those 3 dots. You don't want them there. It was just a placeholder. So the things I want to change is I want to, so give it a comma here on the CX equals 0.1, give it a comma, come right below it. I want to change the line width of the points to 0. If you remember when we did this map on the previous exercise, if we don't do this, the line width is what comes out. We don't see the color. What was the argument name we changed for that? Anyone remember? LWD, right? For line width. So line width equals 0. And then comma right there. And then finally, I just want to make this as Esri world imagery. I'm going to help you out here. The argument is called map.types. We're going to say equals to, and then Esri.world imagery with the E, the W, and the I uppercase. If you run that and then you print it, you should be able to see that interactive map is still raw. We just filtered out some observations based on a subjective threshold. I just subjectively selected 3,000. This is not statistically based, so it's just subjective decision just for visualization purposes. And the reason why I'm assigning these to an object is because I want to be able to call this object again later in the script. All right, so we have the raw EOMap, both static and interactive. Awesome. So today, I want to be applying 5 filters here. So we're going to do min and max yield, min and max speed, and position. All these 5 filters were part of the paper that you all read. So I anticipate you're familiar with them because you already read about this paper and some of these filters here. Okay, so beginning with the min-max filter. I want to start off with just making this plot here that you've already seen this plots from the EDA of the previous exercise, which is just a geom density and a geom rug on the distribution of yield pounds per acre. This is the statistical distribution. It's not the spatial distribution of this data. But this is what we have right here, right? So we see that first, there's a lot of points at or near 0, which some of them are probably errors. There is a few points that are very high in the distribution, which are probably also not accurate. And we're already seeing that there's an effect of speed on some of those very high values. Right, so that helps us to create some of this understanding of what some of the things we have to do. All right, and then I just want to ask for a summary. You've seen this before, but let me just do it here, a summary. I want to ask a summary of yield 17 W $ yield pounds per acre. I just want a summary of that column specifically because I want to focus on that. So here is the statistical distribution in numbers of yield. So basically putting this visual into a table. So minimum is 0, maximum is over 4,000. The median is 121. I'm sorry, 1,217. And the mean is 1,150. Then we have the first quintile and the third quintile. We're going to be using some of this information here to determine how and when and where to filter this data. And I think if you read the paper, you may remember of how that was done. There was a list of steps that these functions are using the statistical distribution of yield and determining some cutout points based on that distribution. So let me see if I can very quickly pull out that paper to show you what we're going to be doing in code. Right here. This is what we're going to be doing. Imagine that this red distribution is our yield distribution, our yield data distribution. We're going to be determining the yield mean and yield max, and then our min y and max y after that. This paper has the functions here, the formulas of how that is done. It calculates some values to get to that. We're going to be applying these formulas to our own data and then determining, using our own data, which points we are considering as errors. So just wanted to show you, this is the visual of what we're doing with our data. Is first calculating the lower and the upper quintile, and then extending that and calling this min y and max y as those thresholds. So any points that are lower than min y or higher than max y are going to be filtered out. All right, going back to our script. So the first thing is going to be to calculate that low quintile. So you can stay in the script, but the low quintile is basically this place in our data. And notice how these values are data specific because they rely on the statistical distribution of your data. So those values are relative to your own data. So let's first calculate the low quintile. The low quintile, based on the paper, is the 10th quintile of that distribution. Which here, the first quintile, I think, is the 25th quintile. We're looking for the 10th quintile. So how do we know what is the 10th quintile of our distribution? we're gonna use here a function that is called, very surprisingly, quantile. So this function, you give it a vector of data. In our case, we want to give it yield 17W $ yield pound per acre. So we're just given the yield pound per acre column. We're not giving all columns. And then it has an argument here for probs. That means probability. What is the probability I want? If I want the 10th quantile, that is probability 0.1. If I wanted the 50th 50 quantile, this would be equal to 0.5, which also happens to be the median. So median is the 50th quantile of a data distribution. In this case, we want the 10th quantile, so 0.1 is the probability we're looking for. If we run this and you print what low Q yield is, this is the value. So 551 pounds of lint per acre represents our 10th quantile of the distribution of the data above. So for us, this is 551 pounds of lint per acre. Now, next, we want to calculate the upper quantile, which is this line right here. So here, the upper quantile, and according to that paper, is the 99th quantile of this distribution. So based on what I just told you, how would you extract the 99th quantile? If somebody can help me here to spell out how that would go in code.
You would write quantile yield $ yield per pounds per acre, then the probability set it to 0.99.
Is this what you said, Polly? Is that right?
Yes.
Yeah, that's exactly it, Polly. Thank you. Yeah, so this would give us what is the yield at the 99th quantile of the distribution. So if you run that and you print it, that value is equal to 1,939 pounds. This means that 99% of your data is at or below this yield value. So we can really see that we have just a very small portion of our data that is an outlier in the upper side of it, right? Because we know the maximum here is 4,274. Awesome. Thanks, Polly. Okay, so now next, let me go to the paper. We have this line. We have this line. Now we want to extend them. So the upper quantile we want to extend above, and the lower quantile we want to reduce to lower than it. That's what we're going to do next. To do that, we need the inner quantile range of what this paper is calling inner quantile range, which basically is just the difference between the upper quantile. So you could just copy that. So IQR get symbol. It's going to be the UPQ yield minus the low Q yield. This is what this paper determines as the inner quantile range, which is a difference of, so between the highest quantile and the lowest, so between the 99th quantile and the 10th quantile, there's a difference of almost 1,400 pounds of lint per acre. Now, the reason why we calculated the IQR, the inner quantile range, is because that is what is used to then extend the minimum quantile to the mean Y and the max quantile to the max Y. So the mean Y here is basically going to be equals to the low Q. So we're extending the low Q downwards. So it's the low Q minus, and then open and close parentheses, 0.25 times IQR. So basically we're taking the IQR, taking 25% of it, and then reducing that amount from our low Q yield. So if you run this and you print mean Y, that brings our lower limit of yield that we're going to accept to 204 pounds of lint per acre. Anything below this is going to get outside of our data. It's going to be filtered out. Now, the same thing we're going to do on the upper quantile, on the upper side of it. So the max Y is going to be our upper quantile yield, so that value that we found for the upper quintile. And then because we are extending out of it, it's a plus. Notice the difference here. So a plus and then open and close parentheses, 25% of the inner quantile. If you run that, and then you print our max Y is going to be 2,286 pounds of land per acre. Any data point greater than this is going to be filtered out. We're going to remove that data point pretty much. All right, so just to I guess this is a good stopping point for us, but just for you to create this understanding then, low Q and upper Q are these lines. This is the low Q, this is upper Q. And then we extend the upper Q above and we bring the lower Q lower for the min Y and max Y based on the inner quantile range. And if you go back to the paper, these are the formulas that they specify there. I'm not making this up. This is all in that published paper. That's why we're following them. All right, make sure you save your script. Today we just go to 4. So let me open here your attendance. You can claim your attendance. And then if you have any questions, I'll stick around for another couple minutes. All right. Yeah, so make sure you claim your attendance, save your scripts. And if you don't have any other questions, you're good to go. Remember that we have an assignment due tomorrow, and then our mini project was moved to be due on Sunday, 11:59 p.m. Let me know if you have any problems, and good luck on your other exams.
Dr. Bastos.